3D solids coming at you. So this is what we're going to talk about. We're going to talk about 4 different types of solids. We have prisms and pyramids, cylinders and cones. Now our cylinders and cones are going to have circles for bases, but our prisms and pyramids are going to have different shaped polygons for our bases. And this is just an intro to three-dimensional figures. So we're just going to spend a little time talking about the different parts of 3D solids and stuff like that. Euler's formula is always going to work with the 3D solid. Euler came up with the fact that vertices minus the edges plus the faces is always going to equal 2. So we're going to talk about the differences of those. To find the diagonal of a rectangular prism, it's basically the Pythagorean theorem in 3 space. Our diagonal squared is equal to L squared plus W squared plus H squared, or you can just take the square root of, obviously, L squared plus W squared plus H squared. Distance formula in 3 space, and the midpoint formula in 3 space. So this chapter gets a little challenging simply because things change. And we're now working in 3 dimensions instead of 2 dimensions. So to find the diagonal of this prism, usually to do a diagonal of a rectangle, you would just go from one corner to the other corner. Well, that's the same with this, except for you have to imagine that you are going diagonally through different type of space. It's not just a 2D figure anymore. You have to imagine that this is a bottom left corner and this is a top right corner of like a Kleenex box sitting in front of you. So not only are you going to be going left and right, up and down, you're also going to be going front to back. So the distance formula is the diagonal squared is equal to the length squared plus the width squared plus the height squared. Okay, and then all you really have to do is add all of those up and, take the square root, and you're just going to end up with a diagonal of square root of 145 or approximately 12.0 something. And that's just it. All you have to do is use basically a 3-dimensional Pythagorean theorem. To find the length between these 2 points, so when you're looking at these 2 points, 3 space is kind of like this. You have your z-axis actually, and then we also have our x-axis and y-axis. So this one right here kind of looks like it's coming out at you. You have to imagine this is like coming out and jumping out of your screen. And this is, going to your right, and this is going up and down. Kind of think of this as like the corner of where your walls meet in your bedroom. Just like the lower corner. And if you go up, you go right, and you can come out this way. So the coordinate 1, 3, 5 is actually kind of like you jump out 1 unit, you jump to the right 3 units, and then you jump up 5 units. So this is actually kind of floating, that far out from this back wall and this far to the right of this wall and then up some. Okay, so that's what a 3-dimensional coordinate looks like. That's why you have an X, Y, and Z. So to find the distance between A and B, you just have to use one really large distance formula where you're still going to use the change in X's. So you're going to do 7 minus 1 squared plus your change in y's, your negative 2 minus 3 squared, plus now your change in z's, 5 minus 5 squared. And after you, again, type all of that into your calculator, you're going to find out that this is approximately 7.8. Okay, so all you have to do is 6 squared plus negative 5 squared, which is 25, plus 0 squared, type it in the calculator, 7.8, done. And midpoint, same as 2 space, except for now we have 3 letters. So you're just going to take the sum of your x's, 1 plus 7 over 2, comma. Your sum of your y's, 3 minus 2 over 2, comma. And then the sum of your z's over 2. And then you're just going to get 8 divided by 2 is 4. 1 divided by 2 is 1/2. 10 divided by 2 is 5. And that would be the midpoint of A and B. All right, so that's basically it. It's just kind of tying three-dimensional objects together. Now, to just back up to Euler's formula, basically, a three-dimensional figure has a couple of different parts that you need to be aware of. Edges are the straight lines. Vertices are just the intersections of all of your straight lines. And faces are the rectangular or triangular or whatever kind of shape that's two dimensions. And you put all of those pieces together. So back when we were talking about Euler's formula, it was the vertices minus the edges plus the faces. It'll always equal 2. We can do that here. Our vertices are, we have 1, 2, 3, 4, 5, 6 vertices. Minus, now our edges are the straight lines. We have 1, 2, 3 in the front. We have 1, 2, 3 more in the back. And then we have 1, 2, 3 that connect the front to the back. So we have 9 total edges. And then the faces, you have to imagine we have this one that I just shaded in, but you also have like this rectangular one on the left. We have this rectangular one down on the bottom. And then you also have to include the front and back base. So this one actually has 5 faces. So then we have 6 minus 9, which is a -3, plus 5 is, of course, 2. So that's it. That's an introduction to three-dimensional figures. This is Longo, and I'm out. See you, bye.